Hi everybody, welcome to lesson 2 in your statistics module. Today we're going to talk about trimmed means. So what I want you to do is flip about 4 pages into your book. 1, 2, 3, 4, about 4 pages in till you see this where it says lesson 2. Now we're not going to be doing weighted means, but we are going to do trimmed means and outliers. Now let's look at the over. This is very easy, this is very fast, okay guys? Now, a trimmed mean is a mean that we find by omitting an equal number of values at the upper and lower ends of a data set. In other words, if we see something called an outlier, which is something that just doesn't belong, we cut the top one off and we cut the bottom one off. So for a data set with outliers, a trimmed mean is better. It's a better measure of central tendency than the complete arithmetic mean. It is always better. So for example, let's look at this. Examine the following data sets: 2, 4, 6, 7, 5, 27, and 3. Now, if I just added them all up, all 7 numbers, and did the irregular old arithmetic mean, I would get 54 divided by 7, because there's 7 numbers, and I would get a mean of 7.7. But look at that. There's only one piece of data that is higher than 7.7. So that means that this is not a good measure of central tendency, because this 27, he's way out there. It's an anomaly. It is called an outlier. So to correct for this outlier, we will use a trimmed mean. Now this is important. If we get rid of the highest number, we also have to get rid of the lowest number to balance out our solution. So let's calculate a trim mean by dropping the highest number, 27, and the lowest number, which is 2. So we're going to drop these guys out. So then I'm going to add up what's left. 4 plus 6 plus 7 plus 5 plus 3. And I'll divide by 5 numbers because I only have 5 numbers now. So 25, they add them all up. 25 divided by 5 is 5. So I get a mean of 5. And this represents our data better, because at least now some of the data are below the mean and some of the data are above it. So it's a better measure. That's it. That's one example. Now turn the page. Turn another page until you see this page. It's got no number on it. All right, the picture with the beaded purse. Isn't that beautiful? Okay, let's do another example of trimmed mean. Quill work, which is the use of dyed porcupine quills to ornament practical and spiritual objects, was traditionally used by First Nations people, including the Cree and the Den. Today, glass beads are more commonly used. Now, Lois is a member of the Kihewin Cree Nation in Alberta. I'm sorry if I slaughtered that. She's well known for her color combinations, designs, and fine workmanship, and her beadwork. So Lois makes note of how many hours she spends on each item that she produces. And this helps her calculate the object's price. So her hours spent on the last 10 purses that she made are follows: 6, 8, 37, 3, 9, 6, 8.5, 5, 7.5, and 9. So what is the mean number of hours Lois spends on each purse? Now, since it doesn't say the word trimmed, we're just going with the regular old arithmetic mean. So I'm going to turn the page and look at the solution. So first, I'll add up all the numbers, and I'll divide by 10. So the traditional arithmetic mean is 9.9. That's how many hours spent on making a purse. So I'm going to flip it back. Now let's do a trimmed mean. What is the trimmed mean for the hours spent? Well, first we have to look at any outliers. So let's look at our data here. 6, 8, 37. That's way out there. All the rest are at least less than 10. And this guy's an anomaly, an outlier. So we're going to get rid of him. So since we got rid of the 37, we have to disregard the highest and the lowest. So we'll also get rid of the 3. And then we'll add up the remaining 8 values. So we'll add them all up, and we'll divide by 8 because there's only 8 numbers left. So we get, what is that? 59 divided by 8. So our new trimmed mean is 7.4. So they're very different numbers. It's almost 10, and this is 7.5 almost. So let's look at question C. Which seems like the more average numbers of hours spent on each purse, and why? This is important. Why? So looking at our numbers, okay, let's take a look at our numbers and go back to our two means. Now, here's a hint. The trim mean is a better measure of central tendency. It is always a better measure of central tendency because of the 10 purses made here, only one took more than 9 hours. So if we use the arithmetic mean of 9.9, that really doesn't show the middle. Does that make sense to you? Now, let's look at question D. What might explain the outliers? Explain them. This is a common sense type question. So any answer you put here will be right if you can kind of justify it. So now if you've ever seen how much work goes into making one of these beaded purses, man, it is incredible. There's a lot of work in here. So let's look at this outlier, 37, right? That could be explained by maybe she had to do she had a commission for a specific purse to build a really large purse with an intricate design. Maybe there's a matching wallet attached, who knows? Now, the outlier of 3 hours, which is very low, could be explained because maybe she just did beadwork for a very small purse, right? Or a purse with a very simple design. Maybe it just had somebody's initials. So you could have another answer here, and I would accept that, as long as you can justify it. Okay, now I'm going to flip into the middle of the book now and do one more example and give you your homework. So if I can go all the way over to lesson 3.2 on page 122, trimmed means. You know where else they use trim means in real life? Gymnastics scores. Because what if, let's just do an example here. What if I have a gymnast who gets, I don't know, 5 judges, and she's Canadian. So the Canadian judge loves her. So the Canadian judge gives her a 10. But she falls off the balance beam 5 times and, you know, I don't know, didn't stick the landing. So the other judges give her a score like this, right? Let's make that a 2. Okay? If I am the Canadian judge and I give the gymnast a 10, her mean, her average is going to go way up. It's going to be very high, and it will be skewed. It won't be fair. So in real life, for things like gymnastics and figure skating, they always get rid of the high one and the low one. What if this is the US judge and he hates us anyway? So even if we did do perfect, he gave us a 2. Bye-bye. Your score don't mean nothing. Now, I would add up these 3, and I would end up with a mean of about 6. Or 5.8 or something like that, which is more reflective of the score. Anyway, let's go to another example. Okay, this is just the same thing that we've done already. Okay, just reminding you, a trim mean is the mean calculated by disregarding, meaning throwing out, an equal number of data points from both ends. So you cut the head off the snake and the tail. Here's another easy set. The data set contains the following values: 3, 9, 5, 8, 4, 6, and 20. Calculate the arithmetic mean. That's just regular old mean. So here's question A, and here's the solution answer for that, A. I will add up all of my numbers, and there are 7 of them. I'll add them up, divide by 7. So I get an arithmetic mean of 7.9. Now question B says, identify the outliers. So here it is, 20. It's clearly an outlier. It does not belong here. Then we'll calculate the trim mean. Then we will explain the difference between arithmetic mean and trim mean. So I'm going to turn the page so I can look at the answer here on page 123. So we already did it. To identify outliers, sometimes you can't see them obviously. So if you want, you could organize the data in ascending order. You don't have to, but sometimes it's very helpful. And then I'll cross off my head and my tail. So I will add them all up. I'm left with 5 numbers once I've trimmed it. So I will add those 5 numbers up and divide by 5. And I get a trimmed mean of 6.4. Now recall 2 seconds ago, the arithmetic mean was 7.9. So let's look at the answer for question C. This is just another method if you want to use this one too. It doesn't work for me. I like this one. So the answer to question C said explain the difference. Well, the arithmetic mean of 7.9 and the trim mean of 6.4 are very different. The trim mean is considerably lower than the arithmetic mean, And that's because we had a high outlier, which raised the mean. In the trim mean, although the 3 was also omitted, it was not so different enough from the other numbers to counteract the effect of the 20. So any way you want to word this is fine, as long as you can justify your answer. Okay, that's the lesson. Now, let's go circle your homework. On page 124, all of it. 1A and B, 2A, B, C, and D. On page 125, 3A, B, and C. You don't have to do that page or the next two. Let's go all the way over to page 129. And you'll do question 1, A, B, and C. And question 3, A, B, C, and D. And that's it. And next time we'll do the final lesson, and then you will work on your practice test in the back. Now before I go, I wanted to show you guys, in case you want to laugh a big giggle, this is this book I got for what kids have really written on tests. And you can see I've dog-eared it because there's so many favorites. But for today, I just want you to have a giggle and look at this, because we're going to do probability next, by the way. Look at this. This diagram shows a fair spinner. Which color is the arrow least likely to land on? Now look at the next one here. There are 300 students in the 10th grade. Mary and Mark want to find out the 10th grade's favorite color. Mary asks 30 people, and Mark asks 150 people. Mark says, my conclusions are more likely to be reliable than Mary's. Why does Mark think he's right? Because Mark is a man. My husband just loved that. And the last one, taking us back to geometry. Polygon. Draw a polygon. All right, guys. Have a good day. We'll see you next time.